of the day, everyone. My name is Dr. Sarika Joshi. I am the Assistant Professor at AISSMS College of Hotel Management and Catering Technology, Pune. I welcome you to the session under the Bridge course, section Chemistry. In the last session, we have seen what is matter, what are the types and the properties of various states of matter as solid state, liquid state and gaseous state. Continuing with the same chapter, this session is based on thermal equilibrium and effects of heat on matter. The objectives of this session are to understand what is thermal equilibrium, to understand what is the effect of heat on solid state of matter, to understand what is the effect of heat on liquid as a state of matter, and to know the effect of heat on gaseous state of matter. There will be enough examples provided in the session to understand it well. Let us first understand what is thermal equilibrium. Heat flows from warmer objects to cooler objects. When a warmer object is in contact with the cooler object, it will transfer the heat from it to the cooler object. This will go on until both the objects have the same temperature. At this point or at this stage, we call it as thermal equilibrium. Let us take an example to understand it better. For example, a bottle of soda is taken out from a refrigerator and is been placed on the table. The table now is at room temperature and will transfer the heat to the bottle. Eventually, their temperature will be equal and thermal equilibrium will be achieved. We see a lot of such examples in our day-to-day life. Now let us understand what is expansion of matter and what is contraction of matter. Most matter that we have seen earlier, when heated, contracts when cooled, expands on heating and contracts on cooling. The very two common examples of the effects of heat are a boiled egg and a thick glass cracking when hot water is poured onto them. The increase in the size of the object when they are hot is called as expansion, and the decrease in the size of the objects when they are cooled is called as contraction. The atoms or the molecules in a solid state vibrate at all temperatures. This is applicable to solid as a state of matter. As the temperature increases, the atoms or the molecules of solid vibrate more vigorously and pushes the atoms further apart. The volume of the solid increases and the expansion is said to occur. So in this figure we have a hot state of matter here and a cold state of matter. So when solid is cold, the atoms vibrate more slowly and they become closer together. The volume of the solid decreases thus as the contraction occurs. Now let us have a look at the expansion and contraction application to the liquid as a state of matter. So what happens to a liquid when a heat is provided? When a liquid is heated, the molecules of liquid have more energy and so they move more vigorously. The moment of the molecules gradually overcomes the forces of attraction between molecules, allowing them for a greater freedom to move over greater volumes. So what happens here? The liquid expands. At a lower temperature, the molecules of the liquid have less energy as compared to when they are heated, and so they move closer to each other. This causes the volume of liquid to decrease and the liquid contrast. I hope you have understood the expansion and contraction of solid and liquid as a state of matter. Let us now see what happens to gases under expansion and contraction. So the molecules of gas are far apart. They are compared when to a liquid or a solid as a state of matter. The gas molecules now move at a high speed in all directions. If a gas is confined in a container whose volume is variable, the volume of the gas will increase with the increasing temperature and will decrease as the temperature drops down. When a gas is heated, the molecules become more energetic. They move faster and further apart. This causes the volume of gas to increase and expansion is said to occur. At a lower temperature, however, the molecules move very much slower due to less energy. They are close together and causes the volume to decrease and contraction occurs. So far we have seen the contraction and expansion of solid, liquid and gaseous as a state of matter. Further, once we understand the fundamental of contraction and expansion, let us see its application in our daily life. I will share ample examples to explain you this fundamental. The effect of expansion and contraction of matter can be very troublesome at times, and hence precautions have to be taken. We can also apply the principle of expansion and contraction in making instruments in our daily life. Let us have the look at the examples to show the use of contraction and expansion of matter. On this particular slide, you can see a picture of a thermometer. So, which metal is found in the thermometer? Yes, it's the mercury. Now, mercury is a liquid metal which expands and contracts if there is a change in the temperature. This apparatus then is used or is suitable for the temperature measurement, and hence it is used as a thermometer. So that is how we can check the temperature in the clinical thermometer. Another example to share is a bimetallic strip in a fire alarm. Let us see its application. An automatic fire alarm uses a bimetallic strip to switch on the electric bell when there is a fire. The heat from the fire causes the bimetallic strip to bend towards the contact point. So what has happened here? Expansion. When the bending strip touches the contact point, the circuit is completed and the fire alarm rings. So you must be really wondering that how the fire alarm rings when there is a fire. You can see in this particular diagram the working of an automatic fire alarm system where a bimetallic strip is used. Another example is the bimetallic strip as a thermostat. The bimetallic strip is also used as a thermostat in an electric iron for controlling and maintaining the temperature. I am sure each one of you must have observed the application of temperature control in the iron that you use at home. So as the temperature rises, the bimetallic strip bends away from the contact point and cuts off the current. Sometimes you can even hear a click sound that is an indication of the varied temperatures in the iron. When the bimetallic strip cools down, the contact is made again and the current flows once more to heat up the iron. That's how the iron can maintain the temperature. You can see its pictorial explanation in the given image. Moving forward, bimetallic thermometer. The application of bimetallic thermometer is a strip wound in a spiral and that can be used to make a thermometer. The metals which are used are brass and invar with a brass on its outside, and as the temperature decreases, the spiral is wound tighter and the point will move towards left. For better understanding, please have a look at this particular image representing a bimetallic thermometer. Its application can be seen in everyday use. Another example, a very common one, is of the railway tracks. I am sure all of you have travelled by railways, and the tracks you must have seen how they are attached each other. Applying the concept of contraction and expansion over here, when laying tracks of the railways happen, the gap have to be left between the successive lengths of the rail to allow the expansion on the hot days. So in the adjoining figure, you can see a small gap between the two rails. Without the gaps, the tracks buckles and this may affect the safety of the train. So there has to be a scope for the expansion when the temperature outside is heated. When concrete roads are laid down, the gaps normally which are filled with bitumen are left between the sections. Again, this is done to allow the expansion in hot days, or let's say in summer. Structures like steel bridges, overhead bridges are built with gaps to allow expansion, as these bridges have the inclusion of the metal. And as we have seen in multiple earlier examples, that when a metal is heated, it expands. So sometimes one end is supported by rollers which allow the bridges to expand easily when heated. So ideally they are not heated over here, but since it is affected to the external environmental changes, in case of very hot days, there has to be a scope for the expansion of these metals. So far we have seen the expansion and the contraction examples in multiple such things such as bridges, railway tracks, iron, etc. Let us move further and see a few more examples. Electric transmission cables. I am sure you all have seen this. Yes, they are also called as cable cars. Cable sags on a hot day and tighten during the cold night. Again, as these are placed in the external environment and there is a constant change in the temperature of the environment, there has to be a scope for contraction and expansion. These allowances have to be made so that the cable functions well. Overhead cable sags in hot weather and it tightens in the cold night, as just explained. Have you come across this problem ever? A very tight bottle cap can be removed easily. When there is a problem removing the cap, you have to just immerse it in hot water. What happens then? The cap expands much faster than the bottle, and so it can be easily removed. Try out this at home. Also, the hub of wheel is usually slightly smaller than the size of its axle. Now to fix the axle into the hub of the wheel, the axle has to be put in liquid nitrogen. Can you figure out the temperature of liquid nitrogen? Well, it can go up to minus 190 degrees Celsius. So cool so that it will contract immediately and it will fit into the hub. Metallic tires. The metallic wheel of the train are fitted with metallic tires. I am sure all of you have seen the wheels of the train. Now to ensure a tight fit, the tire is slightly smaller in diameter than the wheel. And before fitting it, the tire is heated uniformly, which results in the expansion, and this enables the tire to be slipped over the wheel. When it is cooled, the steel tire contracts and make it a tight fit. Aren't these principles easy to understand with these examples? And of course, we are always seeing them in our daily lives, but wondering how does that exactly happens. So the phenomenon of contraction and expansion is applicable here. You can see its pictorial explanation in this particular image, wherein a fitting of a metal tire is happening into a metal wheel. Now once we have understood the contraction and expansion in the states of matter, let us see what happens when heat is applied, what is absorption and radiation of heat. Well, all objects can absorb and can give out, that means radiate heat. But some objects absorb or give out heat better than the other objects. This differentiation is based on their properties. The ability of an object to absorb and give out heat depends on the type and the color of the surface. Dull or shiny, or it is light colored or dark color. Just to give you an example, black color absorbs heat. So here the absorption is based on the color. The rate in which heat is absorbed and the rate in which heat is given out also depends on the surrounding temperature of an object. So in case you are standing near the gas range, obviously the absorption is more as the surrounding temperature is warm. Some applications of absorption and release of heat that we can see in daily life are, first and foremost, most of the buildings when they are painted or the interior of the house when it is painted is always painted in a white or a bright color paint. Why is it done? So that less heat should be absorbed and the interior of the house can be kept cool. White and bright surfaces are good reflectors of heat and poor absorbers of heat. Let us see another example. The oil tank of an oil tanker is painted silver so that it becomes good reflector of heat. This is safer. Why is it? As less heat will be absorbed by the petrol which is inside the tank, or it may invite for accidents if in case it is painted in a dark color, as dark color will absorb more heat and may be problematic for the petrol tank. Oil storage tanks are always painted with shiny aluminium paint so that it reflects the radiated heat and it keeps away so as to keep the oil content cool. Another example in daily life is the base of the heating utensil or a pot, which is usually dull or black. This makes it a good absorber of heat. Since we are going to cook in that particular pot for which we apply heat, the heat will get easily absorbed. So next time you go to your kitchen or you move around, please observe these applications of contraction and absorption of metal in your daily life. So far, in this particular session, let us do a recap what we have seen. We have understood what is thermal equilibrium. It is the equality in the temperature of the two metals. Secondly, we saw the application of heat on different states of matter as solid state, liquid state and gaseous state. What happens to the molecules and atoms of these states of matter upon application of heat? And we saw certain examples related to them. Next, we saw what is contraction and what is expansion of molecules. And to understand it better, we saw multiple examples where contraction and expansion happens and daily life applications or apparatus or some things like tires or bridges like thermometer, iron, daily utensils. We have seen so many examples related to them. So I hope you have understood the concept well, and now you can apply or observe it in your environment. Thank you so much for watching this session. Have a good day.